Hello everyone and welcome back. In this video we are going to understand one of the most important concepts in modern artificial intelligence, and that concept is called Retrieval Augmented Generation, or simply RAG. Now before understanding RAG, let us first understand the problem that exists with traditional large language models. And because of that, they can answer many general questions very fluently. But there is a serious limitation. These models do not have direct access to your latest documents, your company files, your private database, or any real time updated information. They only know what was present during training. So, if you ask something outside their memory, they may either give incomplete answers or sometimes generate completely wrong information. This problem is commonly called hallucination. The model sounds confident, but the information may not be accurate. So the question becomes, how can we make a language model answer using external trusted knowledge instead of only depending on training memory? And this is exactly where retrieval augmented generation comes into the picture. Retrieval simply means searching and fetching relevant information from an external knowledge source. This external source can be PDFs, documents, websites, databases, research papers, Excel files, company records, customer chats, or any custom data. Generation means using the large language model to generate a final natural language answer. So, in simple words, RAG works like this. Instead of asking the language model to answer directly from memory, we first retrieve the most relevant information from an external source. Then we provide that retrieved information as context to the language model. And finally, the language model generates a much more accurate and grounded answer. This makes the output far more reliable. Now let us understand the complete RAG pipeline step by step. The very first step is data collection. Here we gather all the external knowledge that we want the AI system to use. For example, suppose we have company manuals, medical reports, legal files, educational books, or customer support documents. All this raw information becomes our knowledge base. Yostem to. The second step is chunking. Large documents cannot be directly processed efficiently, so we break the documents into smaller meaningful pieces called chunks. Each chunk may contain one paragraph, one section, or one idea. This is done so that later the system can retrieve only the most relevant small part instead of searching the whole document. The third step is embedding. Now each chunk is converted into numerical vector representation using an embedding model. These vectors capture the semantic meaning of the text. That means chunks with similar meaning will have vectors close to each other. This is very important because machines cannot understand raw text directly in an intelligent searchable way, but they can compare vectors mathematically. The fourth step is storing these vectors in a vector database. A vector database is a special database optimized for similarity search. So now our complete knowledge is stored in vector form. Next comes the user query. Suppose a user asks a question. That question is also converted into an embedding vector using the same embedding model. Then the system compares this query vector with all the document chunk vectors stored inside the vector database, and it retrieves the topmost similar chunks. These retrieved chunks are the most relevant information related to the user's question. This stage is called semantic retrieval. Now comes the augmentation part. The retrieved chunks are attached with the original user question. So instead of sending only the question to the language model, we send the user question plus the retrieved supporting context. Now the language model has actual external evidence in front of it. And using this evidence, it generates the final answer. This is called generation because now the response is not blind prediction, it is context aware generation, and this dramatically improves factual accuracy. So this full process is called retrieval augmented generation. Now let us understand this with one simple example. Suppose you have built a chatbot for a hospital. A patient uploads a blood report and asks, what does this result indicate? Today, abhiran instant sample. A normal LLM may give a general medical answer based on common training knowledge, but a RAG based system will first retrieve relevant pathology ranges, disease guidelines, previous patient documentation, and trusted medical references. Then it will send all that context to the language model. And now the generated answer becomes much more specific, accurate, and useful. This is why RAG is becoming extremely popular in real world AI applications because companies do not want generic internet answers. They want answers based on their own internal data. Now let us quickly discuss the major advantages of RAG. Number 1. Improved factual accuracy because answers are grounded in retrieved documents. Number 2. Reduced hallucination since the model is not forced to guess blindly. Number 3. Access to private knowledge. You can connect your own PDFs, files, websites, CRM, or internal company database. Number 4. Real-time updatability. You do not need to retrain the whole language model every time data changes. Just update the external documents. And number 5. Cost efficiency. Fine tuning a huge LLM is expensive. RAG often gives much better practical results at lower cost. However, RAG also has some challenges. If retrieval quality is poor, output quality also becomes poor. If chunking is not done properly, the right context may not be found. If embeddings are weak, semantic search may fail. So, building a good RAG pipeline requires proper document engineering, proper vector search optimization, and prompt design. But once implemented correctly, RAG becomes one of the most powerful architectures for enterprise AI systems. Traditional LLM answers from memory. RAG answers from memory plus external retrieval, and that small change makes a huge difference in reliability. In the coming years, retrieval augmented generation is going to become the foundation of practical AI products. Because the future is not just smart models, the future is smart models connected to smart knowledge. Thank you so much for watching this video.